How's it going now? Hope y'all are having a good afternoon so far, or good day. All right. It's going well. Doing well. Do you have any questions on anything, first of all? Well, I wasn't sure if I needed to go through the test review because I've already made a video on that. But if there were specific ones that you wanted me to respond to, I could certainly uh, do those now. Like if you have specific questions about different problems, or even general questions. But if you just want to ask questions, that's fine. Because I already have a video that I linked in the announcement yesterday that you should be able to go through and watch, and I'll go over the review there. So I thought we would take this time to go over specific questions. Problem two on a whole. Okay. Let me bring that up on the computer real quick. Sorry. Okay. And then 15, 14, and 15. Good. Let's see. First of all, the way that I set up these questions in the Canvas exam, which is, you probably received a notification that there is an assignment now for test one, and in Canvas, both sections of my statistics class, they kind of share the same course. So when I made the announcement, it's basically the both classes. So the other class yesterday already has the opportunity to start, although I don't think anyone's taken the test there yet. But it's already available. But again, it'll be available through next Tuesday evening. 11:59 next Tuesday. So the goal is to have it done the day before Wednesday's class next week. Um, but anyway, the way that I posed question two from the review is that I'm set it up as a multiple choice question. Each part would be a separate multiple choice question. For instance, 2A, we have, and that's probably off screen. Let me change that. Water temperatures of 6 swimming pools on a given day. Okay, now set up as multiple choice with 3 answers. It's either categorical, quantitative discrete or quantitative continuous. Sorry. Just making sure that's on screen. Alright, so the question, which one is it? Well, when we talk about temperature in particular, temperature is a value that is numerical. Okay, when we talk about the temperature of an object or the temperature of water in this case, temperature is a numerical variable, so we think this will be quantitative first of all. But since it is quantitative, we still have to decide, is it discrete or is it continuous? Okay. So the question is a temperature going to be a discrete or continuous quantitative measure? Well, discrete would be countable, and continuous is generally regarded as measurable. So when we think of temperature, do we count it, 1, 2, 3, 4, 5, 6, etc., or do we measure it where it can be any value on the entire spectrum of temperatures that we experience? So which one do you think that's going to be? Continuous, right. So in that case, we would choose option C. Okay. So I tried to set up questions as multiple choice where I could. That means all of the first 4 questions are basically multiple choice, although, well, actually the first 3. The 4th question is actually a matching problem set up in Canvas in the quiz. Hopefully that illustrates it a bit. Let's look at B, and I'll switch to the screen. Okay. So B, we're talking about the lifetime of 12 flashlight batteries. And so when we think of our 3 potential answers, categorical, quantitative discrete, and quantitative continuous, when we think about how long a battery will last, is it first going to be categorical or quantitative? What we're talking about, is it a numerical measure that is either countable and measurable, or is it a non-numerical measure and thus categorical? Quantitative, right? Yeah, when we're talking about measuring the amount of the lifetime of batteries versus temperature of water, those are all quantitative values. Okay. Now, when we talk about the amount of time that the batteries last, is that a countable number or is it a measurable number? Measurable, yeah. And so, because it's measurable, we would then say it's quantitative continuous. Mm-hmm. So it's actually kind of the same as part A, right there, where it was also quantitative continuous. It's really the same concept. When we talk about the amount of time the batteries will last, It's not like we're just making a count. It could be any number in the range of possibilities. Okay. When something is continuous, when something is measurable, that means it can hit all the fractional or decimal values in between. Now, we contrast that with problem C here, where we're talking about the number of bicycles that are sold in 1 year by a large sporting goods store. We're talking about the number of bicycles. Which of the three answers do you think best fits here? And again, we're thinking, do we count the number of bicycles or do we measure the number of bicycles? Discrete. Yeah, quantitative discrete. Yeah, so C would be quantitative discrete. Good. And then D, classification of students in college, whether they're a freshman, sophomore, junior, or senior. Which of the three does that turn out to be? So I said categorical, quantitative discrete, or quantitative continuous. Okay. It is categorical. That's correct, Carson. When we talk about labels, in this case, such as someone either being freshman, sophomore, junior, or senior, anytime we're labeling something, anytime we're describing something in a non-numerical fashion, this is always going to be categorical. Okay? And when you look at all four of these problems together, and I said qualitative here, but I actually put categorical on the test, so I'm sorry for that confusion. When we look at these four problems together, we measure temperature with numbers, we measure time with numbers, and we count the number of bicycles with numbers. But we don't really, in the literal sense, we don't assign a number to the freshman, sophomore, junior, or senior. I guess we could say we're in year 1, year 2, year 3, year 4, but that's not necessarily true anymore in the general sense. For instance, my brother took 6 years to get his bachelor's degree for various reasons that we won't go into. But so he was a freshman the first year, and then it wasn't just year 1, 2, 3, 4. It was 4 categories that the college considers, and that's more significant to the college than the actual number of years, unless it gets to a certain point. So, if we're just assigning a label like freshman, sophomore, junior, senior, or we might have a daycare where we talk about the children in a daycare, whether they're infants or toddlers or a little bit older children, for instance, then we would still have the kind of the same thing. It would be categorical. Anytime, again, non-numerical labels is kind of what we're thinking of with categories. It's like, what can we use to describe an individual, which again is not in a measurable or accountable way. So it's a little bit of a tricky question, but hopefully you'll be able to discern the meaning there. All right. Does everyone have any? Does anyone have any more questions on number 2? Okay. Now, Daviana, you asked about 14 and 15 as well. I was trying to combine two words and it was coming out good. So we have 14 and 15. Is the data skewed or symmetric? Explain and support or answer. 15 is the data compact or spread out? Explain and support or answer. Now, for those problems specifically, I would refer you to the formula sheet here. When we talk about whether something is symmetric or skewed, I want you to use the comparison between the median and the mean to help us figure that out. Okay. Likewise, if we want compact or spread out, I want us to use the range rule to sort that out, which uses the range compared to the standard deviation. Now, before we can actually answer those questions 14 and 15, let's go back to our data right here. And I'm going to go ahead and switch to the desktop camera. Good news, I did buy some batteries finally for my calculator, so I thought I would go ahead and demonstrate how to enter all the data into the calculator here as well. Before that though, let me go in and clear out the existing data, which is actually the data for your test. Alright. Now, we have our list of numbers that we need to input into the calculator. We have 25 values in this case. And so, let me get out of this and demonstrate. So on this calculator, on the 83s and the 84s, we would press Stat. And we want the first option, Edit. Just press Enter. And it brings up our lists. Now, we actually have 6 lists in these calculators. Maybe more, I think. No, just 6. Rather than just the 3 that I had in the smaller calculator. But really it's not a concern because we're never going to use more than 2 at once, probably. Anyway, so Jacqueline, I said when I wrote qualitative, that's the other word that we use for categorical. So qualitative and categorical are the same thing. I have just been using the word categorical, and on the review I happened to type in qualitative by mistake. It's actually going to be categorical in the test, just so you know. Okay. So here we'll go ahead and just enter the numbers one at a time. So we'll enter 25, press enter, 32, press enter, and so on as we go through the list. Okay. 45, 28, 28. 52, 25, 32, 30, 20, 35, 25, 15, 24, 20, 18, 25, and 19. Okay, that should be all of our data. So we go through and enter all the data that we're given into our column. Specifically, the L1 column, so that we can, even if we put it into L2, we can still access it. We just have to make sure we enter the right number. And that's the only thing, is we have to know where our data is stored so we can successfully access it later. Okay. Now, in order to get our statistics from the calculator, we'll press Stat. And on the graphing calculators, we want to go to the Calc column. So we'll go right to Calc, and we see 1-VAR stats. It's the same function we used on the smaller calculator, but it's in a little bit different place. We'll go ahead and press Enter there. Now at this stage, the smaller calculator gave us a screen such as this one, well, exactly this one, but this will actually be, if you have a TI-84, you will actually see a very similar screen to this, in which case you'll press Enter, Enter, go down to Calc, and press Enter. Because our data is stored in list 1, L1, frequency is just 1, and we'll just go down to Calculate and have it give us the answer. On the 83 specifically, this one, it's a little bit different because, okay, we press 1-var stats, but now we have to tell it where our list is that we have all the data in. Now at the bottom, well, on our numbers here, if we look right above our numbers 1 through 6, we have L1, L2, L3, 4, 5, and 6 on the second level above those numbers. So I will press second and the 1 button to bring up L1 on our screen. Okay. You know, whichever list everything is stored in, we'd enter the appropriate list there, L1 in this case. And then we press Enter, and it'll give us the statistics. So, just from this, I'll go ahead and write some of these down. X with the bar over it, appropriately called X bar. That's our mean. Okay. We also have SX, which is 9.97. That's our standard deviation. And we arrow down, and you see we have our 5-number summary that we talked about before. Our median, right here in the middle, is 25. And the last thing that we need is our range. Now our range is not given on the calculator, but we know range is equal to the maximum minus the minimum value. That's on our formula sheet. And we can see here our maximum is 52. Our minimum is 12. And so we have a range of 40. Okay. So we have our mean, we have our standard deviation, we have our median, and our range. Now, as you look through the questions, we'll need almost everything on this list. We'll certainly need like the quartiles Q1, Q3. That'll help us find the interquartile range and find the fences and then test for outliers. And we need our 5-number summary to sketch our box plot in number 13. But to answer 14 and 15 specifically, these are the 4 values that we need. And we'll have already found by that point in the test. So what we'll constantly be doing is referring to previous results. Okay. So knowing that get that out of the way now. Knowing that we have a mean of 26.2 and a median of 25, we want to compare the median to the mean. So our median is 25, our mean is 26.2. So we can say in this case the median is less than the mean. Now, if we go back to our formula sheet, right here, if we think that the numbers 25 and 26.2 are close enough, we could call it symmetric, although because it's more than one apart, I would probably say no, they're not close enough to call them about equal. So instead, we look at whether it's skewed left or skewed right. Well, we found that our median, 25, is less than the mean, 26.2. And so, as a result, our conclusion would be that the data is actually skewed to the right. Okay. Okay, now, and that's the other thing that's important here. If you think they're close enough, you can go ahead and say it's symmetric. So the way that I'll want you to answer this, and you can see how it's phrased in the question in 14. Explain and, what was the other word I used? Explain and support or answer. Okay. So we have our median and we have our mean. If we feel that these are close enough together, then we could say, the median is approximately equal to the mean, therefore the data is roughly symmetric, we could say. I wouldn't say it's exactly symmetric, but pretty close, because there's a little bit of difference there. So we could say our answer is symmetric because the median is about equal to the mean, or we could say the answer is skewed right because the median is smaller than the mean. Whichever way we choose to go with this will be right as long as we can justify with our numbers. So if we feel this close enough, we call it symmetric, that's fine. I'll count that correct when I go back in and grade that. Okay. If you think the median is definitely less than the mean in this case, then we can say skewed right. And if that's your justification, that the median is less than the mean, that's perfectly fine. That's correct also. So I'm going to be a little bit flexible here. Personally, I think the difference is large enough to say it's skewed, but it is a bit of a judgment call. So if you want to go ahead and say it's symmetrical, that's fine. Now, it would absolutely be wrong to say skewed left because it's not the case the median is larger than the mean. Okay, so there is an exception here that I would not be able to accept skewed left as an answer because there is no justification for that. I think we could say skewed right, and I think we could also say symmetric depending on how close we would need them to be to say they're close enough. And it's really the same when we work with the range rule. We're going to compare the range divided by 4 to the standard deviation, S. And so, whether they're close enough to call them a normal bell-shaped distribution, or one is definitely larger than the other, whichever way that goes, we can make our decision based on that. And our support is that comparison between the numbers. In this case, with 15, we want to take the range divided by 4 and compare that to the standard deviation. Now our range, we calculated as 40, so if we divide that by 4, then our range divided by 4 is just 10. And our standard deviation was 9.97. And so here, I believe the comparison is it's approximately equal. Okay. I would say that these are absolutely close enough to say they're about the same number. In fact, if we rounded the standard deviation to one decimal place, it would be 10.0. Okay. And so in that scenario, I would say yes, they're the same, and so we can say it's a normal bell-shaped distribution. So it would be neither compact nor spread out. It would actually be a normal bell-shaped distribution because we found that r divided by 4 is approximately equal to the standard deviation, s. Does that make sense? For these two problems on the test, what I've done is I've left you a text box to input your answer into. Really, you'll just have to write one sentence there, which is the option we choose, whether it's in the case of 15, whether it's compact or spread out or normal and bell shaped, whichever one of those three we choose, and our justification then that follows that, we would say because r divided by 4 is about the same as s, or is equal to s. Okay. And so I'll have to go back in and grade those manually, whereas a lot of the problems are set up as fill in the blank or multiple choice or matching, which the Canvas will grade itself once you submit it. It has the correct answers inputted already. Even for the fill in the blank ones, I'll probably go back and double check your answers there, and if there's a small mistake, like instead of 26.2, like you wrote down the mean is 26.1, like maybe you entered one of your numbers a little bit wrong into the calculator, I'll probably go back and count that as correct and fix that. And then from that point, anytime you use the mean, I'll make sure that your results match the number that you had in that problem. It will take me a little longer to grade because of that, but I think that'll be the most fair way to grade everyone's work, is to, if you're a little bit off on your calculation, I can accept that, but I don't want you to get a problem wrong later because you were a little off in your initial calculation. If your interpretation of these problems is correct, but you happen to be using a problem or value that is wrong, I don't want to count off for that. It's your interpretation for 14 is correct, even if it turned out your median you found was 20 instead of 25. I'll count off earlier in the test where you say the median is 20, but then your interpretation will still be correct here. Okay. Basically, I'll try to give it as much benefit as I can. But like I said, it will take a little bit longer to grade because of that. Also because I have 3 different classes of statistics taking the test. So that's the other reason. It'll take a long time to grade. So it'll be due next Tuesday night. So maybe I'll have it graded the following Monday, but there's no guarantees with that. And again, when you submit your grade, when you submit your test for, when you finish your test and you submit it, it's going to give you a grade. Now, when you see that grade, first of all, don't panic because it's not your actual grade. It may be a number in the 40s or 50s, but that's because I still have to go back in and grade like the problems where you had to upload your graphs or you had to fill in the blanks and write a short answer. I still have to go back in and manually grade those. So the grade that you get won't necessarily reflect your overall grade on the test. So I had a lot of students last semester panicking when they submit their test. Why is my grade a 45 when half the test is multiple choice? This is for college algebra. And the rest of the other half was for, like, show your work. I still have to go ahead and grade the show your work part. So there's no need to panic just yet until I go back in and kind of finalize everyone's grade. And I'll let you know when that happens. Okay. And then you can decide whether or not to panic. It's first test. I wouldn't panic regardless, because even if you do poorly on the first test, um, you'll still be able to recover that on later tests if you do better. That said, this is probably the easiest of the tests, so I hope everyone does well here. Not to put any pressure on you. I don't mean to do that. So. All right. Are there other questions on the review? Problem 4. Good. Let's see. Don, the reason I... Oh, yeah. The reason I'm not going over the entire review is I already have a video just going over the review itself, which I did link in an announcement yesterday when I talked about Test 1. So I'm addressing specific issues beyond just that review today. And it may be that a lot of the questions I'm answering now are part of that review, but it's nice to have that interaction, I think, beyond just me going over the review. But if you do have a question that you're especially concerned with and you don't want to wait to go over it on the review, I can spend some time now and go over it, because I think we'll have enough time to go over whatever we need to. Okay. For number 4, I'm going to match each sample on the left with the sampling method on the right. So A, in the large school district, all teachers from 2 buildings are interviewed to determine whether they believe the students have less homework to do now than in previous years. So first thing I want to say is this is set up as a matching problem in the Canvas exam. So for each part, you'll have a drop-down menu. You choose which one it is: random, systematic, cluster, or stratified. But you're only going to use each one of these once. That's the other thing about that. And I don't know if it actually specifies that in the Canvas test, but that is what should be happening. We use each one of these once. So we can also do this as a process of elimination if you like. It's like you might figure out 2 right away, and then it's just down to the other 2 where you have to figure out which one goes to which one. That's just general advice. Anyway, in a large school district, all teachers from 2 buildings. Now, this is really the key statement here. All teachers from 2 buildings are interviewed. What that tells us is that we've kind of broken up the school district into the individual buildings, whether each school is just one building or a combination of buildings, whatever that means. We're thinking of the buildings as different groups of teachers. Okay, so the buildings are representing different subgroups. What we've done is we've chosen 2 buildings to use, 2 of the subgroups, but we're gathering information from all the teachers in each of those buildings, so each member of those subgroups. Now there's actually 2 of our tests, or 2 of our sample methods that involve breaking the sample up into multiple subgroups, and that is cluster and stratified. Now A in this case is actually cluster, just to confirm the answer. In cluster sampling, we split the individuals up into groups, buildings in this case. We only select a couple of these groups, in this case 2. But then we collect information or data from all members of the selected groups. So from all teachers from those 2 buildings, we collect our data. All right? That's what makes a cluster. Now, I want to jump ahead to C because this is actually the stratified one. Mail carriers of a large city are divided into 4 groups according to gender and according to whether they walk or ride on their routes. 10 are selected from each group and interviewed to determine whether they have been bitten by a dog in the last year. So we've broken them up into groups, in this, which is the same as A basically. But instead of selecting all individuals from just one of those groups, for instance, we've selected 10 individuals from each group. And usually it's by random, so it might say 10 individuals at random from each of these groups. But by selecting individuals from each of the subgroups, that's what makes it stratified. Okay. Now, frequently in the past, I've seen students mix up these 2 answers. So it's certainly something to be concerned about. Yeah, cluster and stratified are kind of close together as far as how they're defined, so I do recommend that you pay attention to the details here so we can figure out, which one exactly are we talking about. Okay. So the fact that we've broken them up in the groups and we select whatever number from each group, that's what makes it stratified. So we have a certain number we get from each of the subgroups. So each subgroup is represented in a stratified sample, but in a cluster sample, we're only looking at all individuals from a few of the subgroups, not all of the subgroups. Okay. Faculty chosen to serve on a committee are selected by drawing names out of a hat. That's random. Okay. And then every 100th hamburger package produced is checked to determine its fat content. That is systematic. Anytime it says every 100th, for instance, or 10th, or 50th, whatever number we use, if we're just going by every so often, that's always a systematic approach. Hopefully that was helpful. Were there other questions? Yeah, and honestly, that's the biggest concern, I think, is telling those 2 things apart. I think most students are already pretty adept at distinguishing which one's the random sample and which one's the systematic one. It's really the other 2. Yeah. Yeah, and like problem 2 and problem 1, I actually just set this up as a multiple choice question, so you'll either select observational study or designed experiment. Now, the difference between the 2 is that observational study, we're just recording information. We're not trying to influence anything. We're just trying to make a record of what has happened. Whether that's given to us by the individual or we witness it ourselves. Okay, we're just collecting information. When we talk about a designed experiment, the idea is that we're trying to influence a certain outcome. Okay, and we're trying to examine. We're applying what's called a treatment, which we then want to see how a situation changes based on that treatment being applied. In this case, when we say a newspaper sends a survey to its subscribers in order to collect demographic data, the newspaper isn't trying to influence the information that it gathers, it just wants basic demographic information, which is like your age, your number of years you've lived in the city, things like that. You could include race if you wanted to, or gender, or things like that. So that's demographics. But all the newspaper is doing is collecting information. It doesn't want to influence any of the information they gather because they want it to be accurate. And so that's really just an observational study. Okay. When you look at part B there, subjects are randomly assigned to 4 groups. Each group is placed on one of 4 special diets: a low-fat diet, high-fish diet, a combination of those two, and then a regular diet. After 6 months, the blood pressures of the groups are compared to see if diet has any effect on blood pressure. And so, in this case, by assigning a different diet to individuals in those different groups, that's the researchers are applying a treatment. And then they try to measure the success of that treatment by comparing the blood pressures at the end of the duration of the research. Okay, so B is absolutely a designed experiment, because not only have we broken them up in the groups, but we've given them different treatments to each of these groups, and so we're trying to influence a particular result. How does the diet affect the blood pressure? Once you understand kind of the basics of the different types there, these usually stand out pretty well against each other, which one is which. But, as you might expect, with just 2 of these, one's going to be one and one's going to be the other. I'm not going to give you 2 designed experiments, for instance, because I want you to be able to distinguish between the 2, so you'll have one of each. So in that sense, you could consider it a matching problem. And the same is true on number 1. It's basically 2 options, and I'll have one for each, one that's descriptive and one that's inferential. Okay. All right. Yes. So when we say something is descriptive, we're just describing what happened. We're just kind of saying this happened and then this happened. Okay, we're not. Oh, absolutely. We're not trying to make any claims based on the data that we collected. We're just saying this is the data we got. Okay. That's what descriptive is. Inferential means not only do we have the data, but now we're trying to make a prediction about the overall population. Okay, what does this number that we found tell us about the population that we're studying? Okay, so descriptive statistics talk about a sample, where inferential statistics talk about a population. So we describe a sample, but we make predictions about a population. That might be a better way of saying that. So descriptive refers to a sample, but inferential takes that sample result and then makes predictions about a population. So A, of the 82 nurses that worked during Labor Day weekend, 32 worked at night and 50 worked during the day or afternoon shifts. In this case, we're just explaining what happened. This is the data that we collected. 82 are working, 32 at night, 50 during the day. That's purely descriptive. It doesn't try to make any predictions about how many nurses will work during Christmas weekend or whatever. It just talks about Labor Day weekend. And B, an economist estimates that the average income of lawyers in Texas is $198,500. Now, the key word here is estimates, because that tells us that one, the economist has a sample that they're working from, and two, they're now making a prediction about the population of lawyers in Texas, specifically their salary. And so, or not salary, income, which is kind of the same thing, but not exactly. Because we're making a prediction, we're estimating, that makes it an inferential statistic. Okay. It really depends on how it's phrased. So, if we had said an economist studied lawyers in Dallas, for instance, and found their average income to be $175,000, for instance, that would be a statement just about those lawyers that were sampled. And so that would be a descriptive statistic. But now, because we're taking whatever sample we had, and now we're making a prediction about all lawyers in Texas, unless we took information from all lawyers in Texas, then this is definitely going to be a prediction, and that's what makes it inferential. Hopefully I haven't said too much and confused you further. Okay. Okay, were there other questions that we want to look at on the exam? Or sorry, the review? Not the actual exam. Yes. Let's turn off the screen. No, we'll go back to a big calculator. Actually, I can show you in both. On the 83, I actually have different data in here, so it's not going to be the same number. Turn it on first. So I hit Stat and Edit. And this is where we would enter the data. And then we press Stat again. We want the Calc heading, so we arrow right. Calc, we want our first option here, 1var stat, so we press Enter. And we press second and the 1 button to enter L1, because that's where our list is located, L1. And we press Enter. Now, we arrow down, and now we can see their 5-number summary at the bottom. We have our minimum, we have Q1, the median, Q3, and the maximum. So Q1 and Q3, we have both of those right there. Okay. It's a similar process on our smaller calculator. So you press Data, that goes to our lists of data. I'm going to use L2. It's a little bit different data, but it should work. We press second and data to get to the functions we want to use. In this case, we want the one variable stats, 1-var stats. And it's actually the same option we chose up here. Okay. So we arrow down to that, we press Enter, and I want to use the data that's in list 2, so I'll actually arrow right here to L2. Frequency is always going to be 1, we're not going to mess with that. And then we go Calc and press Enter. And we have all the same data. Well, actually, it'll be different data for this, different stats, because it's different data in this calculator. And we just keep arrowing down until we finally get to the bottom 5 numbers, the 5-number summary, and we see Q1 and Q3 right there. Okay. If you have a yes. If we have a TI-84, the steps are sort of a mix of the two. I think you'll be able to figure it out. But let me know if you don't. Alright, so the box and whisker plot. Yeah, we have our 5-number summary right here. Let me write that down. So our minimum is 12. Our Q1 is 19.5. Median is 25. Q3 is 32. And our maximum is 52. Now, before we do the box and whisker plot, we actually have to go through and find the interquartile range. We have to find the lower fence and the upper fence, and we have to determine if there's any outliers as well. So the interquartile range, IQR, we know is Q3 minus Q1. In this case, 32 minus 19.5, and so that comes out to be 12.5. Good, yeah. Our lower fence is Q1 minus 1.5 times the IQR. Q1 is 19.5 minus 1.5 times, and then the IQR is 12.5. We just found that. And so our lower fence is equal to yeah, 0.75. And then our upper fence is Q3 plus 1.5 times IQR. So that'll be 32 is Q3 plus 1.5 times 12.5. So our upper fence $50.75, right? Now, we have to look at whether or not there's any outliers here. Now, so if we go to our data set, and let me just bring that up. Here's our data set right here. And actually, it's a little bit easier if you use your stem and leaf plot once you have that. Do we have any of our data values that are smaller than the lower fence, 0.75? Well, our smallest value here is 12, and that's bigger than our lower fence, so there aren't any outliers on that side. Okay. Lower fence is 0.75. It's definitely smaller than all of our data, so it's not a concern there. The other question is, we look at our largest number, 52. Well, that's our maximum value. We know that. But our upper fence is actually 50.75. So 52 is larger than that. Since 52 is larger than our upper fence, what does it make 52? An outlier, yeah. So 52 is an outlier because it is larger than the upper fence. None of our values are smaller than the lower fence, so only that number is an outlier. Potentially we could have more than one, but in a data set this size, realistically, we should not expect that to happen. Okay. So that's the data that we needed, and let me switch back to the paper. There we go. That's the data that we need to create our box and whisker plot right there. So what you'll want to do is we'll make a number line, and if you want to use a ruler, then definitely go ahead and do that. But we want to mark off some units here. Now I'm going to start at 10, and I need to count by 5s, so 15, 20, 25, 30, 35, 40, 45, 50, and 55. That way all of our data values are between these numbers, so we should be okay there. I'll go ahead and mark off 4 points between each of these numbers. Try to equally space them as close as I can. It does make it a little bit of a challenge to plot the 0.5 values, for instance. Okay. So now, above this, I'm going to graph each of our 5-number summary values. We have a minimum of 12, which is right here. Our Q1 is 19.5, so I'll try to draw that halfway between 19 and 20, which is a very small difference. So it's okay if it's not perfect. Median is at 25. Q3 is at 32. And our maximum is at 52. That's our 5-number summary. We'll draw a line connecting these, but not going any further. Sorry. It's a little hard for me right now because I can't quite lean right over the top of that. So anyway, draw vertical lines for the middle 3, and we'll close that up as our box. Okay. Now our fence, our lower fence, is at 0.75. Now I didn't include that on the graph, but it's over here somewhere. And our upper fence is at 50.75, which is actually a little bit before our last data value. So again, I just scratched that out, so ignore that part. This is our final dot, and it doesn't go any further past that. But our fence is at 50.75, which means it's to the left of our maximum value. And this is an outlier, so we'll make an asterisk there. Okay. And so that would be our box and whisker plot. Okay. And again, you'll do that sketch on your own paper. You won't have to write down this other stuff because you'll already have done that for the previous parts of the exam. So this is all that you'll need for problem 13, is it? So this is actually problem 9 right there. The IQR is actually part of number 11, and then the fences and the outlier. this is all part of number 12, and then this is 13 right there. Okay. But again, this will be a file upload problem, so you'll just have to take either a picture or a scan of your sketch, whatever you have, and then just upload that into the exam. Okay. Are there other questions? No. No, it's too much trouble. Do expect everyone to be, what's the word? I forgot the word. I expect everyone not to cheat, basically. So, I mean, you do have the opportunity, but you do have a time limit, so remember that. If you're going in cold, you're not going to have enough time. So, anyway. So make sure you study the review a little bit further. I can actually show you this much. So you go into quizzes. Here's test 1. Click on that. So when you get the instructions, first of all, for each problem you either need to answer a multiple choice question, fill in the blank, or upload a file that shows your work for a question. Be sure to accurate or completely answer each question, because some of your work will still need to be reviewed by me after you submit it. The grade you receive will not be completely accurate as to your performance in the test, and you will be able to see the correct answers once the due date has passed. So you won't see them right away. Like once you submit them, you'll just know what your grade is, but you'll be able to eventually, once everyone's done their test, you'll be able to see what the correct answers are. So, at least for like the multiple choice and the fill in the blank stuff. Then I go through and I included this, which is our formulas. It's actually an image of the formula sheet that I whatever I did, I added to the document. And then I also added calculator instructions for the 8384s and then the 36X. So yeah, the calculator instructions for both. And then finally we get down to question 1, which is not on the review, but it's just a academic honesty and integrity pledge. So please get that one right. It is multiple choice. Please pick the right answer. And beyond that, then you have the actual test itself. I went ahead and counted that as some points just so everything comes out to 100 points even. I made it a little bit easier from a grade scale, or grade point. Anyway, going back to the previous page, you do have 120 minutes. Okay. You do not have multiple attempts. And I went ahead and shuffled the answers. So the answers you see, like for the multiple choice, are going to be in different orders for everyone's test. So I don't think that's a big deal. It's just how it is. I think it's nice. Anyway, and you'll be able to see the entire test at one time. So if you don't want to work the first problems first, you can go do the later problems first and come back to the earlier parts, whichever you prefer. Now, the chapter 2 and 3 stuff is like all kind of dependent on each other, so there's not a whole lot you can do out of order there. But if you wanted to come back and do like the chapter 1 questions last, you could do that. So, again, no lockdown browser, no webcam required. Now on the final, you will have a proctored exam, whether that's via webcam or in person. So You will need a histogram, and so what you'll do is, like we talked about with the box plot, is you'll need to draw it out on your paper best you can. And again, feel free to use a ruler if you're worried about neatness. And then just take a picture or scan it, and then send that to me. Okay. Other questions? It will be for the frequencies, though, if that's the other part of your question. Yeah, it will be for the frequencies. Okay. All right. Now, I did post other information about the test in an announcement yesterday. Again, that had the link to the other video I made. So I definitely recommend that you watch that. If you have other questions on different parts of the review that I didn't cover in class today, I just went through the whole review for the other class. So, and I want to recommend to them that they watch this one because I go into more detail on certain things here that probably they will appreciate. So, all right. So that's it. On Monday, we will not have a lecture. We'll not have a stream. So basically, I'm allowing you that time to take the exam if you want to on Monday. But again, you could take it any time between now and Tuesday evening next week. So if you only have the time available during class, I want you to use that time. But especially for those of you that are, working full time and everything else, so feel free to use that. But otherwise, you do have some freedom as far as when you can take it. If you feel that there's a better time for you, where you think you'll be more relaxed, more comfortable, and able to do better on the test. So, all right. So I think we'll leave it at that for today. Anyway, our next lecture will be next Wednesday. I probably won't have the exam results by then yet, so we'll just start some new material on Wednesday. Actually, what I'll do, rather than new material, I think we'll talk about the first part of the project on Wednesday. I'll go ahead and get that ready for that class. And you'll have a couple of weeks to do that part of the project, and I'll probably shorten it a bit from what I had previously given, because normally what I'd like to do is a group project where we can have time in class to work in groups. We don't really have a great situation for that right now, unfortunately, so I'll probably just make it a little bit shorter as a result, because everyone's going to do every part of the project now. So, anyway, we'll talk about it more then, but the first part of the project will cover similar material as we talked about on this first test, so it should go nicely with what we've already discussed. So anyway, if you all have other questions, feel free to email or send me a message through Canvas. Y'all have a good weekend and good luck on the test, and we'll meet again next Wednesday. Y'all have a good day.